Today we are going to explain a method for accelerating the turn-off of MOSFETs. First of all, here is our driver IC, which is an input chip. This pin here is its outie output pin. First, when it is at a high level, the signal passes through this 10 ohm tri-level drive resistor and then comes down this way to reach the base of our PNP transistor. Now, since the base of the transistor is at a high level, it will not conduct, so the signal will go through this diode to reach the gate of our MOSFET. Now, there is a voltage difference between the gate and the source, so the MOSFET is in a conducting state from the drain to the source. If, for example, the IC chip outputs a low level, which is 0 volts, then this 0 volt voltage will be applied to the base of this PNP transistor. Also, inside this MOSFET, there is an intrinsic capacitance, and the capacitor can store, say, a voltage of 15 volts. The positive end of this 15 volts will be applied from the gate to the emitter. Now, the emitter is at 15 volts, and the base is at 0 volts, so there is a voltage difference of 15 volts between them. The transistor can then conduct, allowing a large current to flow from the emitter through the transistor to the collector, and then return, bypassing the chip. In this way, the turn-off speed and effect are much better. If you enjoyed this, please consider following us.